Okay, this is an integration by substitution question. It says integrate x squared over the square root of x minus 2 with respect to x using the substitution u squared is equal to x minus 2. The first thing I like to do in these is to sort out how I'm going to change my dx to get it in terms of du. So we do that by looking at our u squared, and normally what I do is differentiate my u with respect to x to see what I'll get, and then I'll be able to rearrange. But it's a wee bit difficult here to do it here. I'm going to show you a couple of ways you could do it. So the first way is just to use like implicit differentiation. So I'm differentiating both sides with respect to x, but this I'm really doing, the first thing I'm going to have is differentiate this with respect to x. You have to do that by doing 2u du by dx, and on the right hand side is equal to 1. And then from there, you can say that's 2u du, the integral of 2u du, the integral of 2u du is equal to the integral of dx, which tells me I'm going to replace my integration sign and the dx by the integration sign and 2u and du. So that's really what it tells me. Right, if you don't like that method, I'm going to show you another way of doing it, which I would really prefer in this one, where you had your u squared is equal to x minus 2. You could just then make x a subject, so that's going to be just x then is equal to u squared plus 2, and then what you're going to do, you've got x as a subject, you're going to then say I'm going to differentiate my x with respect to u. So it involves you having to do this bit of implicit differentiation, which people aren't very fond of. So here, if you do that, you differentiate the u squared with respect to u, you're just going to get 2u, differentiate 2 with respect to u, you're going to get 0, and then you can do the cross multiply thing again, so dx is equal to 2u du, which is mathematical nonsense. Slap an integration sign around it, and then mathematically it makes sense. So you've got the same thing two ways. You've got your integration sign and your dx gets replaced with the integration sign 2u du, just as it had done over here. So whichever one of those you prefer. Okay, so we've sorted out the integral sign and the dx. We know we're replacing it with an integral sign 2u and du. We now have got to sort out x squared, and we also have to sort out the square root of x minus 2. So we'll do the x squared bit first. We know u squared is equal to x minus 2, which means u squared plus 2 is equal to x. And we wanted to find what x squared was equal to. That means x squared is going to be equal to that thing squared, u squared plus 2 squared. So x squared will be equal to u to the power of 4 plus 4u squared plus 4. Okay, the next thing we've got to sort out then is the square root of x minus 2, which is on the bottom line. So again, we're using our identity that it gives you. It tells you in the question, it tells you that x minus 2 is equal to u squared. So we'll just write that down. X minus 2 is equal to u squared, which means then the bit that we wanted, square root of x minus 2 is equal to square root of u squared, which is just u. So let's just recap on what we've done. We have, bear with me, we have changed our integration sign and our dx to the integration sign 2u du. We've changed our x squared, we've got it now in terms of u, and we've just got worked out that the square root of x minus 2 is just u. So we're going to put all of those things in, and then very importantly we're also going to tidy up. So we put all of those things in. I'm going to say I, which I will recognise as meaning the integral, is equal to the top line we'd worked out to be u to the power of 4 plus 4u squared plus 4. And the bottom line, that was a square root bit, worked out to be just u. And remember, we placed our integration sign with the integration sign and 2u du. Now what happens here, well, what you need to do then before you can do anything else is cancel out a wee bit. So I'll use my green here just to cancel out. You can see this u on the top line and this u on the bottom line cancel out. And then just multiply in by the 2 would make life easiest. And then that's just going to be, that's going to be our 2u to the power of 4 plus 8u squared plus 8. And that's being integrated with respect to u. So the next part of the question is just integration. So we're just integrating that as you always would have integrated. So if you integrate that, you will get Raise the power by 1, remember, divide by the new power, so you're going to get 2u to the power of 5 over 5 plus 8u cubed over 3 plus 8u, and remember your constant of integration c. Okay, you could, the question, remember, is in terms of x, so they would want you to give your answer in terms of x. You could put your answer, your x values in at the moment, so just put it back in. You know what u is equal to, or sorry, you know what u squared is equal to, so it's maybe not too easy putting it in this form. What I like to do is tidy this up when it's in terms of u. So we're going to change, I'm going to take a common denominator here. We have a 5 and a 3, so the common denominator is going to be 15. And to make life easier, I'm going to make that 8u over 1, so then we can see what our numerators are going to be once we take a common denominator of 15. So I'm putting that all over 15, I'll still have my c outside. The 5 here needs to get multiplied by 3, so its top line gets multiplied by 3, so it becomes 6u to the power of 5. The 3 here needs to be multiplied by 5, so its top line gets multiplied by 5. 5 times 8 is going to be 40, and that's u cubed. And this 1 here gets multiplied by 15, so the 8 also gets multiplied by 15, and I have done that, and I've got 120u. And remember, I've still got my constant of integration out, so it doesn't disappear. And then if we go on down, you can just about see that. I'm just gonna write that again so I can see it, and then move on down. Bear with me a wee second. Okay, now still I'm going to tidy this up. Top line, what I could pull out is just a 2 and a u. And I'm going to write my 15 over here on the bottom line. And what I'm going to have inside is 3u to the power of 4. And if these are even powers, you'll see why in a wee second. This makes life so much easier for us. Then 20 u squared, and then plus, and it's just going to be 60, and then plus c. And now is the time then to start putting things back in terms of x. Remember, u squared was equal to x minus 2. That means, we'll do a couple of these, that means u to the power 4 would be equal to x minus 2 squared, and also u would be equal to the square root of x minus 2, or x minus 2, to the power of 1/2. So that's what we're going to put in now to hopefully tidy this up a wee bit. Okay, I'll just move down the page a wee bit, give myself a bit of room, and then we'll say we have got our 2 over 15, and that was times u. And remember, over here we've said now that u is equal to x minus 2 to the power of 1/2. So that's just going to be brackets x minus 2 to the power of 1/2. Then inside this bracket we have 3 lots of our u to the power of 4, which we now know and love as x minus 2 squared, plus we have 20 of our u squared, which is x minus 2, and then we have plus a 60, and then don't forget your constant of integration. Okay, the 2 over 15, x minus 2 to the power of 1/2 is fine, don't do anything with it. Then we have a good bit of tidying up to do in here. We've got 3 times x minus 2 squared, which is going to be x squared minus 4x plus 4. And over here, you're going to have plus 20x minus 40 plus 60, and plus your constant of integration. And again, a bit of tidying up and showing all my steps here, just to minimize my mistakes, because I make plenty. We have 3x squared minus 12x plus 12 plus 20x minus 40 plus 20. I'll just write it out the long way. And then plus your constant of integration. And my last line, 2 over 15 times x minus 2 to the power of 1/2. That's going to be times 3x squared. Then we've got our x terms. We have minus 20 plus minus 20x plus 20x is going to give you 8x. And in your numerical terms, I'll do these two first in my head. I'll do minus 40 plus 20 is going to be 60. Sorry, minus 40 plus 60 is going to be 20. And then plus the 12 is going to take me up to 32. And then plus my constant of integration. And as far as I can tell, that is, well, it's certainly one variation of the answer. I would imagine there'd be lots of different ways of writing this. Whether or not they needed you to go as far as this and do all this factorizing, I do not know. We'll have to wait and see when the mark scheme comes out to see. They could well have been happy enough with you just putting it in up here putting your x values in. It's not easy when you've got the u to the 5 and the u cubed and so on. They may I've been happy to do it, but I think that's the way I've done it. It certainly makes it doable anyway. When you factorize and leave it in terms of u until you factorize as nicely as you can, and then put the x values back in at the end.